Welcome everyone to another observability clinic. Today's topic is mastering DPL. That's the Dynatrace parsing language. And nobody else would be better to actually talk about DPL than Tiit, who is a principal product manager. Welcome to the clinic. Thank you so much. Tiit, can you please introduce myself and also tell me if I pronounced your name correctly?
Yeah. Hello, my name is Tiit. You pronounce it quite well, comparing to some others in my previous life. So I'm a product manager, as you mentioned, here in Dynatrace. Have been now for a year, and we are dealing with log analysis and security use cases mainly in application security solution here in Dynatrace. And today I will talk to you about how to extract meaningful data from the raw logs that you have ingested into Grail.
Perfect. Yeah, because we talk a lot about DQL, the Dynatrace query language, but the DPL, the parsing language, is a really powerful construct where you on the fly can basically say what type of information do you want to extract out of the data that you have. But you know what, without further ado, Tiit, I know you've prepared something. What have you prepared? And just take it away and enlighten us.
Yeah, sure. So today I will talk about the powers of DPL, so to say, or how the powerful language can actually give you more, let's say, tools to your forensic toolbox in order to make your forensic investigations even more thorough and more precise and more fast, thanks to the preciseness. And I will talk about the DPL Architect, which is the tool that we have built for you, which enables you to learn DPL much faster way and enables you to create those patterns semi-automatically. And I will talk about the matchers that we can use in DPL in order to extract meaningful data, which already has types as well. But I will just reach that point when we reach it, and then we'll bring examples to elaborate that concept more further.
That's perfect. And then also, folks, if you're watching this, we will also post a lot of links in the description of the video. So you will probably have a lot of links to documentation and things. So everything that we are covering today from a link perspective, like links to documentation, to example, you will find it all in the description. Sorry to interrupt you. You go ahead.
No worries at all. Yeah, so this is the slide which has the most text in this presentation, so bear with me. But going through a bit about the background or why we're actually talking about DPL and extracting keys at all. So imagine that if you're the data scientist or the investigator who actually wants to investigate something or perform some threat hunting in your logs or traces or spans that you have ingested into Grail or what you have in Grail. You have certain problems which often occurs when using different tooling when analyzing logs. For example, of course, the first and most crucial thing is that you want to always have access to the data when you need it. You don't want to re-index it, and you don't want to re-import it, rehydrate it on, or deal with the data when you actually need it during an incident, for example. You want it to be available as soon as you need it and right away without spending any additional time, which is, I would say, quite logical. The next step would be that the data that you have in Grail or wherever ready to be analyzed has to be in the form that it was in the original form. So why I'm saying this, we know a lot of tools that normalize logs, and we know lots of tools that already during ingestion time aggregate your logs or make some kind of adjustments to the content, which means that when you're actually looking for that final needle from the haystack, you might not be able to find it because it has already been aggregated. So you want to have the raw events, and this is one of the reasons why we actually enable you to ingest the raw data to Grail without schema, for example. We don't extract any fields or try to pressure the data into schemas. We want to have it in a raw format for you to be able to analyze it later on, depending on your use case, which is, I would say, quite logical. Of course, we would like to be immune to format changes in your logs in the future. So imagine that you have some fixed log format, and for some reason your vendor or your developers or whoever make adjustments to the log format and log something else, which means that, again, during an ingestion time, parsing and schemas, what might happen is that since the log format is changing, it might not get ingested at all anymore. And I will bring an example of this later as well. So immuneness in that sense makes sense. And this is why, again, Grail has the power to ingest data in a raw format. If that makes sense to you, Andy, as well.
Yeah, it makes perfect sense. And actually, this just happened recently to myself, because I updated the library that then changed the log format, and all of a sudden things that change the way I access the data, and I think it makes a lot of sense. Yeah, it's a real life problems, and I guess this is also why we are obviously have implemented and invested in DPL as we have. Yeah.
Yeah, definitely. Yeah, and furthermore, and this is something that I will bring an example of later on as well, is that you want to define the format of the data at the moment when you're actually querying it. So depending on the use case, you might want to have all the data in your log format to be ingested into different fields, for example, for filtering or for aggregations. But in some cases, you only want a portion of the data. Let's say you only want to extract the IP address from the log event, which means that you want to define the schema when you're actually extracting meaningful data during your investigation. And this is where DPL comes to help. And again, I will come back to that topic later. And definitely, and this is something that is really unique for Dynatrace and DPL, we want to have the objects that we extract with a type. So we don't want to have like a string blob or some kind of token that we can then analyze or summarize or search for, but we want to have types to that. And again, this is something that I will then come back to as promised. So yeah, if that makes sense, we can actually continue with the presentation or the storyline, so to say. Well, we actually come back to all those topics that I mentioned right now, if that's okay.
Yeah, makes sense.
So imagine that you're a security analyst in a company, and then you do mainly threat hunting and security analytics for this company. And then the company has hundreds of applications which produce millions of logs or log records per day, and this is all ingested into your log management system, let's say Dynatrace or whichever we are currently using. And now a new wave of cyber attacks is targeting your sectors or the companies in the same sector that your company is working in. And now your chief information security officer runs into the room and wants to understand whether we have been targeted within the last 6 months as well. So now you have a pressure, you have time constraints, and you actually have to deliver some answers the fastest way possible because the C-level wants answers. I would say quite a common situation, having been on the both sides of the CISO chair, asking those questions and giving those answers. It's always quite stressworthy situation to be in. So yeah, real life scenario. So you as an investigator might have the first problem. You want to analyze your logs from a really long period of time, which takes a lot of time and resources. And you don't have any time to rehydrate or re-index or reload the data into your system from, let's say, archived logs from some centralized log server. And you want to have those answers basically by yesterday. So the goal is, or the problem that you have is that you want to have access to the data when you need it. And as a solution, I won't go into too much details because I have seen your channel in YouTube, and I know that we have lots of great episodes, some of which I brought out here as well, which already cover the benefits of Grail and how to ingest data and then how to use that data with DQL, for example. So for this solution, I would say that please watch those videos again, and we can continue with a further problem. But this is relevant for analyzing as well. This is why I mentioned it on the slides.
Yeah, thank you. And also I wanted to highlight here, we just launched a new YouTube playlist, and also the same videos are also on Dynatrace University. It's called Learning DQL, DQL by example and by use case. So folks, all these links that Tiit has put here and also some additional ones, you will also find them in the description of this video. So thanks for highlighting those. It's great content. Thank you.
Yeah. So the next problem that you might have, for example, imagine that your application logs, which they usually are saved in a JSON format, or at least a portion of the logs might be JSON. So for example, the one that we have brought out on the screen as an image here, it contains a payload, which is in the JSON format. And well, usually what is being done, for example, if you have a centralized log server and you are using your command line tools, for example, or you're using some other popular CMs that leverage Regex, for example, you can then write the Regex pattern or this kind of expression to extract JSON. But to do that, it has to be really precise. And what will happen is the portion of the string or the log will be extracted as a string, not as a meaningful object. So if you're familiar with a JSON object, it has like nested fields and it has sub objects and stuff that you might want to query. But if you get only the string literal, well, you can do only so much, if that makes sense. So your problem is that you're trying to solve is you want to extract data as objects which have types. And the solution that we will provide from Dynatrace would be the Dynatrace pattern language that this episode is all about. You can use matchers that we have defined in DPL, which you can find from the manual, and the link will be below the video afterwards, to define the data structure in order to extract the data into typed fields on query time. So this is just an example on the image here. If you define, for example, a JSON and call it a payload, the name after the colon is the title for the field, it will find the first full JSON object. It will not match the two objects as the regex did on the previous picture, but it will match the exact JSON payload, which is now usable as an object as well. And I will demonstrate it later on as well.
Yeah, this makes it super easy, because I always struggle with regex and everything what you mentioned earlier, right? I mean, I don't know who is an expert in regex, but I always struggle. And then just having to say, I want to get the first instance of the JSON in the log line as JSON object. I mean, that's extremely helpful, and just so it boosts productivity as you're accessing and analyzing your logs. Yeah.
Yeah, definitely. And then I will show it in a brief demo as well in just a minute, and how it matches. But just before showing that, just to describe how DPL actually is structured, and how could it well provide additional value to you. Imagine that you have a log record, which is the first portion on the slides, and the colors represent the matchers that I have brought down. The second portion of the data is the TPL full matching expression. So imagine that the log record is as it is. To extract all the feeds from the log records, you only define the timestamp and name it as a TS, or timestamp. You define an IPv4 address, which is the yellow one, to extract the IPv4 as a separate column, not a field, which you can then filter on at least, and then get some additional data on the IP addresses as well. The session as a line data and the username as a line data. And then you can define, for example, DQS, which stands for double quoted string, to extract the whole request, the post request that went towards your application server, for example. And then comes the infamous JSON payload, which extracts the whole JSON as an object. And I will come back to that as well. Then the integer, another JSON, and some DQS as a user agent, which means that you don't have to define any quotes and define that if you have any quotes within this string, then please escape those, and so on and so forth, as you should do in regex. You have the ability to just define that I want a double quoted string, and we already have a matcher for you. So it's quite easy to actually access the data that you have defined here. And yeah, comparing, for example, to regex, if you would like to have the same thing. But as I made an ironic note here as well, it's almost the same, but totally different. So if you can see, one is fluent TPL, which enables you to write the human readable patterns. The other one is write-only regex, which means that you can write it and then debug it later on, which might make it much difficult. But without the joke, debugging later on, or then adding new fields, for example, the IP address, it's quite hard to debug if you are not fluent in regex. So coming and writing an ad hoc pattern to extract fields in regex might be more time consuming than using DPL that we have provided here. And yeah, if we are talking about the types, then again, as mentioned, when you use regex, which is brought on the right side of the slide, you will get a string literal. It's just a string that has the format of a JSON. But if you want to look for a certain value from the JSON, you basically can do a contains search, as you do in DQL. You can only find whether this whole string might contain some substring. When we're talking about DPL, we have the access to the whole object as it would be in, let's say, JavaScript or in other programming languages, which means that if we have defined it as an object, you can actually access the sub-object as I have described down here. So you can only filter out the username value from the user objects from the whole data payload, which means that you can do more precise searching, more precise filtering, aggregations, and whatever you want to do on the data. And it will not give you so many false positives as the first approach would be when you use regex, for example, because James can be present in several fields, but you want to find James is only from one certain field. Does that make sense to you as well, Andy?
Yeah, I mean, as I said earlier, I think you speak to my heart if you take away the pain of regex and also like just string comparisons, because as you said, there's just so much can go wrong here just because the data changes, and then James might be part of obviously of all of a sudden a field name, and then you're actually getting something completely different. Yeah, makes a lot of sense.
Totally. Yeah. So and this is actually the good place to bring you bring a demo to you as well. So
Yeah.
if I will now share my my generated logs to bring out this content, or how would you actually create those DPLs? So imagine that we have those log records here, and now we would like to, let's say, continue from this and start, I don't know, extracting let's say fields. So you click on the result and you have a context menu opening up, and by clicking extract fields, the DPL Architect will open up. What you will see here is the log record that you clicked on, and the green portion is the amount of log record that is being matched by your current pattern. Well, right now it's matching a whole lot because we have only the data here. Data describes the whole field. But imagine that you will write here, let's say, JSON payload. What it does is that the first LD, which means line data, will match everything until the second matcher is coming, which is currently JSON. So the first LD, which we don't extract, is matching until where the JSON begins, and the JSON portion will start from here. So if clicking results, you will see that the payload is the JSON which is extracted from here. Then you can actually do even more better. You have the add to preview button in the upper right corner here. So if you click here, you can actually add more records that you would like to analyze now. Let's add these 3, which means that you can actually see how the pattern is extracting your payload from 4 different log records at once. In the results that you see it the same way. So this is something that we help you to actually create those patterns. And the notebook that you saw before, it had like 1,000 responses. Up here, you see what we call a base data set. So which means that right now it shows that this pattern that we have created matches 100% of the records that you had in notebooks, which means that your pattern is quite complete. It can actually extract quite many data, and you can actually continue your work from here. This is something that we would definitely, like to point out. The second point I would definitely like to point out is that, as you saw, we have the second portion of JSON here as well. So imagine that we would like to extract payload and the result that we got. So we just write LD here to match all the data until the next matcher that we will write here. And the next matcher will be, again, JSON result. Now we can see that 2 JSON portions are being extracted. One is the payload and the other one is the result. And we can do actually relevant actions on both of them if we would have that query in the DQL. So again, 2 objects that we can then manipulate differently and then query from. So, for example, just continuing what we can do from here, let's just skip to the payload. We are happy with this format right now. We will insert this pattern here, and we will re-execute the query. We can see that now the JSON payload is being added as a separate field here. We can see the payload as an object right now in notebooks, which contains this data that we had here. Go back home. And from here, we can actually continue with our investigation. So for example, if you would like to aggregate stuff, let's just add some prepared statements. We will create, just changing the name field, sorry. We will now only keep the field's content. We will extract the field called privileges from the JSON object, and we will extract the username. So for example, if we want to find only such users who has admin privileges that have logged into our system, we can just execute this query. And as you can see, we accessed the JSON sub-objects by referring to those objects in our DQL query. So this is like the cool opportunity that we are able to do here. And just if you want, we can filter again based on usernames and so on, which is in the middle of the string. Does that sound logical to you and is followable?
Yeah, very, very much. And also, folks, for those of you that are kind of new to maybe Dynatrace query language, check out the videos that explain really how the query language works, because what you're showing here, you are first of all fetching all the logs. Then you want to say only the log that comes from the generated.log file. Then you parse, then you can change the fields. You can actually use the fields that you extract from a complex object. Again, use it for filters. So it's really from top to bottom with the pipe operator. And it makes a lot of sense. And it's so easy because you just say, hey, there's a JSON. Just give me the first JSON in my log line and give it to me with the name request. And then I can access every individual field like I would do in a programming language, because I just specify the name of the field. Even nested fields like usernames will give me the username of the user object in the request JSON. It makes a lot of sense, and especially for folks that are dealing with log analytics on a day-to-day basis, and the struggles you otherwise have with regexes or string comparisons. Everybody will love it, and it's easy to understand.
Yeah, definitely. And I can even show you one more trick here, because as you say in DVQ measures, and this is not it, we have actually the possibility to extract concrete or specific fields from JSON in DPL as well. So imagine writing this kind of JSON, which is somewhat more difficult because you would have to define then the fields within JSON. But what happens is that I define privileges as a JSON array, and then I described user as a JSON object, which again has a username as a string object within it, and I can do it in DPL. And since I have put in flat equals true, which means that we will flatten the results out, what will happen is that the concrete values will be extracted from DPL directly. You don't have to actually have DQL present as well. So imagine that I will just extract it like this.
Yeah.
I can do the exact same query without any kind of DQL interruptions, and I see the same results here. So this is the power that DPL provides you. You can extract specific fields as well if you're interested in that solution. It depends highly on the use case, of course.
Yeah, thank you. I did not know this, so definitely learned something new already.
Yeah, so this is like a really cool thing, yeah, that we have done here. So just writing, let's say, if you would like to see, just copy the pattern here, but if you would like to see the usernames and the privileges and the outcome, for example, of all administrative users that have accessed our system here, this is the query, and then this is the results that you would see, which again takes nested objects from JSONs and will show it as a flat table for you to analyze further. So yeah, this kind of flexibility is something that we are like really proud of, I would say.
Yeah, you should be proud of that. Yeah, it's really cool.
Thanks. And yeah, continuing from here. So now if you would like to extract, let's say, all the fields that we have here, we have prepared a DQL, yeah, sorry for that, presentation. Just here. So imagine that we would like to extract now all the fields. We will copy this pattern that I have done here. I can have it on multiple rows as well to just simplify reading. And yeah, so we will have our timestamp that will extract the time. I have defined the time format in simple time format. I have my IP address here. I have my JSON payload. I have extracted username and privileges from here. And I have my result set as well. So I can basically extract timestamp, IP address, username, privileges, and the result that I got from here. So then continue my cool investigation and remove the first ones as well to then see what I can see here. Where from certain fields, for some reason, I haven't been able to extract all the fields, but I will come to that later. Right now, it's somewhat maybe ruining the use case, but we can come back to that one later. So what you want to do, you want to then understand which of the administrative users, for example, have logged in into your system or try to log in with admin accounts without the successful result. So they have either failed or they have attempted and it hasn't been completed. And discover that, okay, I have like users with administrative access attempted and failed here. So you can do like, let's say, some kind of summarization here based on the DQL functions that we have present. For example, I don't know, summarize by result and see the count, and you're able to see that how the division here goes. But I think that Peter Zaar has described the DQL functions here already quite several times, so I would think that we won't have to go over that one. So yeah, but so this is all cool, and this is all something that provides value in case of investigations. But why is this relevant, or why do we want to have this DPL present, or why are we defining these kind of things during query time? Because usually what happens is that, well, life happens, as I say it. what has happened several times in my previous life as well, log formats keep changing. And they might change because, let's say, developer enhances logging, as we said, or the example that you brought, that the library was changed and that changed the logging to a new version. Or maybe some administrator upgrades your software in the application that then introduces some new fields, for example, for logging. Or a simple thing that is not related to maybe software development at all. A network administrator enables an IPv6 in your routers or in your firewalls. And what will happen is that, well, Windows systems tend to use automatically IPv6, but if you have defined IPv4 in your ingest rules, then IPv6 is not handled well. And that will introduce a whole lot of new issues to your logging capability, which means that, for example, if you would take the same query, I will show it to you just in a minute. Here, we will continue from the previous investigation. I just removed some of the filters here. And we would like to see all the logging counts, not only by the administrative users, but all users. Then we can see that, okay, I will change the visualization as well, sorry. Bar chart options. We can see a sudden drop in our logs. So what has happened here? Somebody's probably changed something. So which means that our current pattern is not able anymore to actually parse all the data. Some requests are missing from that point on. So in our case, I know that we have actually changed the IPv ruling. Half of our clients now are using IPv6. Mm-hmm. Since, let's say that we did an investigation, discovered that we had some change. Now, if, for example, we had the schema defined during ingest, then we wouldn't have those logs anymore. They are not ingested because they didn't match the IPv6 pattern, and you don't have those logs. You cannot do any analysis anymore. Mm-hmm. If, for example, you're using Regex, then good luck with that. Yes, you can change your IPv4 to IPv6. This is actually the best IPv6 pattern that I have seen in Regex so far. But again, good luck debugging that if you find a mistake there, or it doesn't parse or whatever, or you want to enhance it. And I know that even in this pattern, there are some mistakes. Some loopback addresses are not parsable by that Regex expression, for example, which means that it's not complete as well. Mm-hmm. But still, in case of DPL, we can only change the pattern. We will only change the pattern that we will have, or what we had. If you remember, we had the IPv4 matcher set in our pattern. If we will change it to an IP address, for example, which is including both IPv6 and IPv4, everything will turn back to normal, which means that, let's make this adjustment here. Instead of IPv6, now we have IP address, and we run this query again. We will see that the log phone normalized. We have the same baseline, and we see some kind of suspicious activity here as well, which means that we actually can continue the investigation. But furthermore, we actually discovered something suspicious as well from our logs, which means that the same kind of questions that our Chief Information Security Officer had, that somebody is trying to enumerate our usernames or trying to log in our system, it would have not been caught if we wouldn't have that possibility to change the pattern during, parsing time. Does that make sense?
Yeah, totally. And I think this is really just like an eye-opener on the power of this, because you have so many built-in types, patterns that you can already use. And it's great that you have kind of IP address as kind of like the generalization for whatever IP address, it covers both. And that you can just easily change it and then just run the query again, right? And you're analyzing all the logs that came in the last 2 hours, last day, last 7 days, or like in your story that you told earlier, right? In the last even 60 days, whatever it is, right? It's
absolutely. And if you see how blazing fast it is, because one of the things that people are actually worrying about or have asked several times is that, but if you are actually executing those things and parsing things on query time, doesn't it make more time? Because Regex usually is quite slow, and if you have lots of logs, it will take so much time. It's blazing fast because we are going through actually a lot of logs. We can query hundreds of gigabytes within seconds, basically. And within those seconds, it's both fetching times, it's parsing time, and it's basically all the analytics that is being done on the Rails side, which means that it's really, really blazing fast. And I cannot emphasize it enough, I would say. So, but yeah, going forward from here, we can actually see what then happened during that time here. We will just since it's UTC time, we have to I will just write like this and then summarize as well to then understand what actually went on during that minute here, because we had this aggregated time to 1 minute. Now we will do a filtering and we will do a summarize by client IP address to understand, do we have any which IP addresses did what kind of activities during that 1 minute? And now executing it, it cannot show it as a chart, which for understandable reasons, we can show it, view it as a table. And now we can see that, one of the IPv6 addresses was actually the one to blame. During that minute, one IPv6 address tried to log in like 201 times for some reason. So it doesn't sound really good. Usually IP addresses or customers don't do these kind of things. So what we can do, we can basically use this IP address, try to then filter out to understand, let's say, filter to IP address, and maybe let's summarize it as well to understand which users and how many users were actually used by that client IP address, not within this specific time, let's say, but during our logging time at all. So again, running this query, we will change again the display as well for prettier view. Oh, not that view, this one. And we can actually see that this IP address, IPv6 address, has tried 201 times to log in to these usernames, and clicking on it, you can see the full user list here as well, which users were actually used, trying to enumerate. And looking at the usernames, they're quite generated. They're not like your normal usernames, which means that this might be a security event or a security incident, even if it somehow got breached as well. You can do additional summarization, let's say client IP and result, to then understand, you see that, okay, all of those were failures. Which means that you don't have to do a further investigation about which usernames were now maybe taken over or something. It was only an attempt, which is a good news for us in case of investigation. But again, these simple adjustments in your patterns and then DPL and DQL will provide so much flexibility during your investigations to then fastly adapt and get your answers within minutes to the questions that usually took hours to analyze. And right now we had the really simple use case where we actually had this, show it maybe again. We had a really simple use case, which means that we had like a log format, which was, yay long. If you can imagine, for example, AWS CloudWatch logs, which are really huge JSON payloads with really many nested objects, and you want to find only a portion of that log, it totally makes sense to use DPL, not only, let's say, grep or string search there. So, So I'm really sorry that I rushed you through all this, because it was maybe somewhat fast-paced from my side. But
this is, for me, it's fascinating. Make sense, at least? It made a lot of sense. And honestly, this is an eye-opener, because every time when you are exposed to a new language, whether it's a query language, or in this case it's a pattern language, people are always hesitant. Why do I need to learn something new? But you made it so easy, especially with with all of the also with the architect here, right? It's great to just start typing in. So what I learned, what I take home with me, ALD is obviously something where you say there's some part that I don't need, but then the next kind of pattern, like in JSON, it will automatically find the first occurrence of JSON. You can give it a name. And so I think this is a great way to start, because I think people will need to figure out, how do I start with this, especially if you're not that experienced. There's a lot of built-in types, whether it's timestamp, whether it's IP address. I think I also saw you when you started typing, there's even like some code completion, if I'm not mistaken. Yeah, perfect. Like all of this, right? There's like, obviously things are documented. There's a lot of stuff going on here. And then also, I guess
we have we have lots and lots of matchers, and this is not it. We are still not done with it. So lots of matchers will add on and so on.
And then what I also see here is, right, some of these types like timestamp, I guess there's a default way to use timestamp, and then you can pass in as a parameter what type of timestamp it is. And so this is really good it gives you a lot of flexibility. Also the DQS, I didn't know about this, the double quoted string, which I'm pretty sure is something that in a lot of logs you have double quoted strings, and this just makes it so much easier because you don't need to do the escaping.
Yeah, definitely. And then just to elaborate here, you mentioned that the LD or the line data is something to skip, but also you can do actually a trick where you actually name it. If you give it a name after a colon, it will actually extract the data that is in the LD as the variable as well. So it's depending on whether you write a name to it or not, it will either be extracted as a field or just it can be a placeholder in the log as well, just to show that, yeah, we have a JSON portion here, but we will skip it because we don't name it, and then it will not be extracted. But you can still use it as a part of DPL. Yeah.
And does LD have a default type? Is it by default string, or what is it?
It's basically everything besides a carriage return or a new line.
Okay.
Yeah.
Very good. And then I know you just showed how to create new patterns. I see there's a save button here. So if you have, if you create, yeah, it's awesome. Yeah, you can.
Yeah, you can. Yes, this is something that I forgot to mention. What we have here is that you can, if you have your favorite query or you have a DPL that you are using constantly, then you can persist it. You can save it in a hierarchy here. You can create folders and then have your favorite patterns saved here. And also we provide out of the box so-called Dynatrace patterns for most usable technology that we have, well, which have proven to be quite popular in when using Dynatrace as well. So for example, if you're analyzing the aforementioned CloudTrail, for example, we have prepared the CloudTrail parsing pattern already for you out of the box, which means that if you are opening up CloudTrail logs, you can apply the pattern that we have provided to you and you don't have to write any DPL at all.
Yeah.
And so on. So, and the technology amount that we are providing patterns for is constantly growing. So this is only the initial set that we are providing to you out of the box. Yeah.
Awesome. Yeah, I don't have any more questions. I think want to get my hands on this. We will share a lot of the stuff that you presented today. Thank you also for this. Yeah, exactly. There's a lot of content. Whether you go to search dynatrace.com and then search for DQL. There's also, as I said, we have already videos specific to DQL and Learn DQL, which has started and launched a new playlist on YouTube as well as on Dynatrace University. So please be aware, the videos are available both on YouTube and on Dynatrace University, so you can pick and choose what your favorite video platform is. And Tiit, I'm pretty sure, as you said, this is not the end. There's so much more to come, and we will have more sessions with you in the future.
Yeah, perfect. That sounds great. And thanks for having me. It was a pleasure.
Thank you so much. All right. With this, thanks for watching this. Enjoy DPL. And if you have any questions, also make sure to go to community.dynatrace.com. There you can also ask questions. A lot of people are out there in the community to then be happy to help you. All right. With this, see you next time. Bye-bye.